a demonstration motor. That's all it is. It's just a demonstration. No real practical application, but that was fun to build. If we want to see how it works, then what we need is a cell. Now I'm trying to build this completely free, so I've got the cell itself comes from an old battery that was for a power drill. This is one of the cells out of it. Because the cells are in series, then we find that there are some very good cells in when we pull it apart, and others which are dead. This happens to be one of the good ones. If we try then to use this on our demonstration motor, put it on, and nothing happens. If I give it a little spin though, then it does rotate round, it keeps going. Difficult to see it's rotating on the camera, but you can hear it bashing about, showing it's rotating. If we stop this then, how on earth does it work? Well, what it has at the end are wires coming in. So we have two wires coming in at the end. Throw everything on the floor. Two wires coming in at the end. Where am I? Over here. Oopsie. So here we have two wires coming in, so the electricity comes in one side up here, and there we have a bare wire touching against this piece of plastic here, and another bare wire touching against that side. Onto the plastic then, what I've done is to put a piece of the end of this coil. So the coil comes round to this end here, one side, and the other side then comes round to this part here. So as this goes round, the side here is always say going to be positive, and that's always going to be negative. Now these wires then go in between the magnetic field, between these two magnets, round here and then back again. Now it's important that the current at this side is always going away from us, and at this side coming back, or vice versa, as long as they're opposites. So to do that, if we didn't have this commutator at the end, these two what we call brushes, although they're only bits of wire, pushing against the coil, then this side would go away from us when it was here, but when it had rotated round to there, it would still be going away from us, so it would try to come back again, and it would only probably oscillate between the two like so. So to get it so that the current is always going away from us at this side, then we have this positive coming on to the wire going down this side, and when we rotate it, this now is still going away from us. Conversely, this is coming towards us, and when we rotate it, this side, the current is still coming towards us. So that then is the commutator, and that's the difficult thing to build, and that's what this is all about. In a real motor, of course, it sets off on its own, because it actually has just the two pieces of wire touching against the ends of the coils, but it has three coils, so that there's always two wires being touched, or one coil being touched, or two coils being touched, so that it then can self-start, which of course mine can't. So how have I built it? Well, I wanted to build it completely free without using any paid for materials. So the things I've used are, I've used a wooden block for the build, because the polystyrene quite simply doesn't work as I'd like it to. I've used bits of cardboard. These are from an apple box, I think it is, from the supermarket. And I've used two other pieces, so I have these two pieces here, and I've cut a little bit out of them so that These are 25 by 60 if anybody's interested, so that I can use an old pen, the barrel of an old pen, to go in between them. I want to fasten them together, but I don't want to pay for glue or tape. So what I've found is that if we use an old milk bottle, the label on a milk bottle remains sticky if you take it off. So I can put those round to stick the bits together. So I haven't cost anything so far. Keep going. Hopefully this has got sticky enough to hold itself together. Something's happened up there which isn't good, so I need to pull those two apart. That's got bent over at the end, so it isn't sticky anymore, so I need to cut that off, and that gets rid of that non-sticky bit. That sticks down there and that sticks round there. Can do the same at the other end. Hopefully my tape's okay. So I stick that bit on, try to make sure I'm not overlapping the ends. So now I've got the bit that can actually rotate, and that's going to rotate on an old knitting needle. So that's that. Got the knitting needle rotating, so we can get rid of this for a minute. And what we want to do now is to wrap some wire around. Where can we get wire from? Well, the wire I've got happens to come from an old TV. It's 0.25 of a millimetre, and it was television. You can get this sort of wire on all sorts of things, old motors, transformers. They use wire in long lengths for its electromagnetic properties. So I'm going to unwind about 4 meters of this wire, and this wire is actually enamelled wire. It has an enamel coating on it so that it's insulated and doesn't short against itself, but I need it to be uninsulated. So what I'm going to do is to clean the end off, about 2 inches off the end. If we do the other end, which we haven't done, have we? Find the other end, and we find the other end, and here we have the other end which hasn't been taken off. We can do it in 2 ways. One way is to use a knife and scrape it off. So we just scrape it off with the knife, or alternatively we can use a bit of glass paper, emery paper, whatever we've got, and then just squeeze it in, and hopefully we can take off the enamel coating so that it is nice and bright and shiny. We're then going to wrap it round our former, so we leave the shiny bit sticking up and hold it in place. One way to do it then is just to wrap the wire round the pen, and then take the wire round, wrap it round, and keep wrapping until we've got however many turns. And then at this end where I've got it sticking up, I'm going to fold it back on itself, and then so it comes back down along the side of the pen, so it's at the side where the edge is here, so that it makes contact along this side, makes contact here. I'm then going to put some sticky around that to hold it in place, and then carry on wrapping round. So hopefully I have one here that I've partially done, typical Blue Peter style, where I've wrapped it round. I've stuck a bit of tape round so we can hopefully see the wire there going up along the side here and then up there. It must be in line with this wire here. Then we've got the other side. We have a problem that it's a bit too long, so what I'm going to have to do is to cut it off. It hasn't worked out exactly right, but I can cut it off to the right place. Just cut it off there, sort of thing. And then I can clean up this piece of wire again, like I did with the other end. Clean it up, and then I'm going to bend it down once it's cleaned up so that it's level and so that it's on the same side as this. When I've done that, then wrap some more wire around the outside so that we've got our commutator here with the wires coming all the way down there at that side, and then all the way down at this side. So that is the finished rotor. And now we need to build the holder. To build the holder then, as I say, I'm going to use 2 pieces of wood and the piece of wood and the 2 pieces of cardboard. I've screwed the bits of cardboard into the bit of wood, and now I need to make some holes through it. Use the knitting needle. Just push a hole through. The knitting needle isn't going to rotate, so it doesn't matter if it's a tight fit. So we want it to be a tight fit. So we can put that through, try and make sure it's level, and push it through like that. So now we've got that there. We can take the knitting needle out, hopefully, and put our rotor onto our knitting needle, so, and hopefully if we've done it right, our rotor can rotate very easily. So there it is, rotating. Now we need to be able to connect up to these pieces at the end, and we need to be able to put up, so they need these pieces of wire coming up to touch and these pieces here. I appreciate not everybody could bend those pieces of wire, so pieces of metal, backplate or whatever. So I've decided to use an old lid off a can, and I've used a piece of wire coming up, screwed down onto the base then for one side of the commutator. If I want to put the other side on, then I've got this here. I've bent it so that it's springy at the bottom. It has a loop at the bottom which hopefully will give it extra springiness, and brought it out round here. I've used a piece of wire that I've stripped the insulation off each end. Don't know why I've left the bit on in the middle, it's not really important. So I can put that onto my board and hopefully use my trusty screwdriver to be able just to screw it in. Right, that's screwed it in. It's not quite in the right place, but we can bend it later to be in the right place. It's important that these two don't touch, else we'd short out our cell. We then need to put on the put on the metal at this side to hold the magnet. So we've got that there. If I can find where it goes, so it goes sort of there. Try screwing it in. Of course it's a lot easier because I've done it well, it should be a lot easier having done it before. Don't seem to be. Try again with another screw. Try to get it in the right place. Got that one right, I think, so hopefully this will just screw straight in. That's screwed in. The one at this side I'm not happy about. Might be alright, let's try it. Anyway, so there we've got our holder. What we need now are some magnets. Where are we going to get magnets from? Well, one place people suggest is from speakers, and these are speaker magnets, and they're quite nice things to play with, but I haven't found those to be strong enough for my motor, so I need some stronger magnets. One place to get magnets from then, which I'm going to use, are off a microwave. Mum always used to call it a microwave, but it's a microwave. These magnets are very strong and we need to be very careful with them. We shouldn't really pull microwaves apart, because the thing that these come off is called the magnetron, and apparently the magnetron has got ceramic insulators on it which are made of barium oxide, or at least some people say. Other people say they're not barium oxide because they're too expensive, and the other thing is that they have to be in powder form for them to be poisonous. So a lot of people don't like pulling microwaves apart. If we don't want to do that, we can get magnets from other sources. There's some here, I don't know where this one's come from, but these strong magnets are very brittle, and this has obviously been bashed and broken, as indeed have these two here. You can buy these off the internet. They're not, well, a couple of quid or something, but we could use those. But what I've used on the first one, the original one here, are a couple of magnets from this device here, which is a tray. Which is used for holding screws and things, but it's a bit big for what I want, so I'm going to chop it down. I've removed two of the magnets and I'll just use this end, cut it across there. So the two magnets on here are the ones off this tray, but for this purpose I'm going to use these microwave magnets, which are very difficult to pull apart, and we need to be very careful with, because they can trap our fingers, and if they trap your fingers it ain't nice. So that's that one on there. I've got to make sure that the two are attracting each other, so they're attracting, so hopefully I can put this one onto this side so that one's a north and one's a south, and they're actually trying to attract themselves. If I take my commutator then, take my knitting needle and put it in, take my commutator or my rotor and put it into there, and then push the knitting needle through. Hopefully it'll go through, and I can check that it's alright because it rotates, and I must check that these two touch against the two wires when it's in a horizontal position. So it's touching the two wires down here in the horizontal position. So now what I need is a cell, and I'll touch that against there. These are a bit bent. I'll bend them round so that it can touch. Oof, that surprised me. So it can touch. Now these normally aren't self-starting. That's not touching. That really made me jump. Put that onto there, and maybe if I give it a push. Nope, I haven't got it in contact. Get it in contact. There we go. And there it is, rotating. Difficult to see it's rotating on the camera because of the frame rate, but it is going quite fast. And so there I think I built, completely free, a demonstration motor. As I say, it's not very good for driving anything, but it shows the principle. So it's bye now. Bye.